Pluto is a distant, dim, and relatively small world that was once considered the ninth planet in our solar system. But it's now back in the headlines, and not for the reasons you might expect. Recent remarks by top space experts Neil deGrasse Tyson and Michio Kaku have reignited interest in Pluto, as they raise an alarming possibility. Pluto may be on a slow but inevitable collision course with Neptune. This isn't idle speculation. Both scientists warn that Pluto's complex and unusual orbit could eventually intersect with Neptune's in a catastrophic way. Could two celestial bodies really be on such a collision course? And what would happen if such a cosmic crash were to occur? Are we seeing a strange orbital illusion, or something far more real and dangerous? Pluto's path already comes uncomfortably close to Neptune. According to Tyson and Kaku, even a minor change, barely a wobble, might be enough to send Pluto on a destructive route. The consequences wouldn't just affect Neptune. Earth could feel the impact indirectly through gravitational disruptions or shifting orbits in the outer solar system. To understand how this could happen, we need to examine Pluto's orbit, one of the most eccentric in the solar system. Pluto takes 248 Earth years to complete a single orbit around the Sun, meaning it hasn't even finished one full circuit since its discovery in 1930. Its path is highly elongated and inclined at 17 degrees compared to the ecliptic plane, the flat zone where most planets orbit. For about 20 years in each cycle, Pluto's orbit actually crosses inside Neptune's. During those periods, Pluto is technically closer to the Sun than Neptune. This raises an obvious question: why haven't they collided already? The answer lies in a delicate celestial dance orchestrated by gravity. Pluto and Neptune are locked in what's called a 3-to-2 orbital resonance. Every 2 orbits of Pluto correspond to 3 orbits of Neptune. This resonance ensures that the two bodies never come close enough to crash. In fact, when Pluto reaches the point in its orbit that intersects Neptune's path, Neptune is always safely on the opposite side of the Sun. Still, this balancing act is far from simple. Pluto's orbit is governed by a 3-body problem: how 3 massive objects like the Sun, Neptune, and Pluto influence each other gravitationally. These interactions are difficult to predict and often chaotic. Scientists use concepts like asynchronous oscillation, orbital drift, and the VZK wobble to describe and analyze the motion. Asynchronous oscillation is what keeps Pluto safely offset by at least 90 degrees when it crosses Neptune's orbital path. Orbital drift, its vertical movement above or below the solar plane, adds another layer of protection. And the VZK wobble, named after physicists Zell, Kai, and Kaku, describes the tiny, rhythmic variations in Pluto's orbit caused by the tug-of-war between the Sun and giant planets like Neptune and Jupiter. While these mechanisms have kept Pluto safe so far, they aren't permanent. Pluto's orbit may appear stable, but it's extremely sensitive to even the slightest perturbations. That's what worries Tyson and Kaku. A slight nudge, from a rogue asteroid, a shift in Jupiter's gravitational influence, or even subtle changes in solar output, could be enough to disrupt this fragile balance. In the 1980s, computational models revealed that Pluto's orbit, while stable over long time periods, is inherently chaotic. Change one variable slightly, its position, velocity, or angle, and the orbit may diverge wildly in just a few thousand years. This orbital chaos means long-term predictions are fraught with uncertainty. Modern data confirms that Neptune, Jupiter, and Saturn all play stabilizing roles in Pluto's path. Jupiter's immense mass, in particular, acts like a cosmic anchor. Its gravitational pull contributes to maintaining orbital resonances across the solar system. But even Jupiter can't guarantee absolute stability forever. If Pluto's intricate balance with Neptune begins to erode, the consequences could ripple outward. Astrophysicists emphasize that while a collision is not imminent, it's not impossible either, just unlikely within the next few million years. Yet the scenario is worth considering because it highlights how dynamic and interconnected our solar system truly is. What appears to be a static system is actually a complex ballet, with orbits nudging and shifting in slow, cosmic rhythms. So why the concern now? Neil deGrasse Tyson, one of the most prominent public science communicators, has long taken a keen interest in Pluto. Not only as the champion of its reclassification as a dwarf planet, but also as a commentator on orbital mechanics. He often points out that Pluto's odd path is a perfect example of how our solar system is still full of surprises. While he doesn't believe a collision is imminent, he warns that Pluto's overlapping trajectory with Neptune is a long-term vulnerability. Michio Kaku, a theoretical physicist known for exploring the extreme ends of possibility, agrees. Kaku is fascinated by the delicate gravitational arrangements that keep our planetary family intact, and how easily those arrangements could unravel under the right, or wrong, conditions. Both scientists argue that studying Pluto's unstable orbit isn't just an exercise in theoretical physics. It's essential to understanding the long-term fate of our solar system. As we develop better simulations, telescopes, and computational tools, we may uncover new factors affecting Pluto's movement, and even detect anomalies we haven't yet imagined. With Pluto acting as a case study in orbital chaos, it reminds us that space is not static but alive with motion, change, and risk. In conclusion, the idea of a Pluto-Neptune collision, while not imminent, isn't fantasy. It's a legitimate cosmic possibility, one that might take millions of years to unfold but underscores the fragile harmony that governs our solar neighborhood. Tyson and Kaku's warnings are not about panic. They're about curiosity, vigilance, and the need to keep watching the stars. Because even out in the farthest reaches of our solar system, danger and discovery are always just one orbital shift away.